Okay, good evening, guys. Sorry we started a little bit late. Yeah, late. We're looking at current electricity. And I think our next series of topic we're going to be considering for some weeks from now. Okay, current electricity, everything has to do with current charges, Ohm's law. It's one of the key aspects that Jamb focuses on, all right, when setting their questions, electricity, and I think magnetism, waves. All right, we're going to cover those areas. Like I told us before, we're going to be doing an in-depth summary of these topics. The bulk of these topics, we've done that in our whole level, our secondary school level, doing our Waec and all that. So we're going to be looking at in-depth summary of these key topics that normally comes out in Jamb exams. All right, so we want to start with potential difference. Okay, we're looking at current electricity. We know current is a flow of charges, and when we're talking of charges, we're talking of electrons, right? The flow of charges. Okay, the flow of charges. Let's start with some key concepts. Okay, in current electricity, potential difference. All right, when a circuit is connected and complete. All right, let me stop there. uh I think there are three types of circuits. Yes, there's an open circuit, there's a closed circuit. Yes, I think two types if I'm not mistaken, two or three if I'm not mistaken, but I know there's open circuit, there's a closed circuit. An open circuit is a circuit without a load or a resistor. Yes, resistor, they are also called load. Okay, while a closed circuit is a complete circuit. It contains load. All right, it contains a load. All right, in a closed circuit, the key is locked, while in an open circuit, the key is open. All right, so when a circuit is connected and complete, rather, yes, and complete also, charge can move through the circuit. Yes, charge, current can flow through the circuit. Charge will not move unless there is a reason, a force to drive it around the circuit. Charge will not move except there's a reason, and that reason is a force to drive the charge around the circuit. Now think of it as though charge is at rest. Yes, at rest. We all know what it means for a charge to be at rest. We have done Coulomb's law in our secondary level. We'll still treat it in this class. Coulomb's law uh, that states that the force of attraction or repulsion between two charges is directly proportional to the product of the charges, right? And inversely proportional to the square of their distance apart. Just are synonymous to the Newton's law of gravitation. All right. Okay. Now think of it as though a charge is at rest, okay, and something has to push it along. This means that work needs to be done to make charge move. Exactly, work needs to be done for the charge to move. A force acts on the charges, doing work to make them move. This force is provided by the battery in the circuit. So when you connect your circuit, you have your resistance, you have your key closed, then you have a battery, the positive and the negative terminals. You have the battery. So this force that is needed to push the charges around the circuit is provided by the battery in the circuit. So a battery has the potential. That is where that word potential difference is coined from. Okay, from this analysis, that is where we derived that word potential difference. So a battery has the potential to drive charge around a closed circuit. The battery has potential energy. Because of that potential it has, the charge is at rest. It has the potential to drive the charge around the closed circuit. The battery also has the potential energy that can be converted into electrical energy by doing work on the charge in the circuit to make it move. So when that force acts on the battery, all right, the potential energy and the battery is converted to electrical energy when the charge now begins to move around the circuit. So a quick definition of potential difference from this analysis I've given so far is potential energy is the work done per unit charge. The work that is done in pushing a unit charge around the circuit is the work done per unit charge. This is a clear definition of potential difference. Okay, the work done per unit charge. Okay, the units of potential difference are volt. I think there's a typographical error there. I think where you have that fractional stuff, that I think that's a formula there. I think the typographical error. The formula is PD equals to W over Q, work done over charge. Work done is measured in joules. Some persons call it joules. Charge is measured in coulombs. So, and potential difference is either measured in joule per coulombs or is measured in volt, which is defined as 1 joule per coulomb. So potential difference is measured in joule, and the unit name is volt, and the unit symbol is capital V, capital V. Okay, next we'll see a voltmeter. All right, a voltmeter is an instrument for measuring the potential difference between 2 points in an electric circuit. I think many of us have seen the laboratory type in our lab. Yes, is the same as the one I have here. It is used for measuring the potential difference between the 2 points in an electric circuit. The symbol for the voltmeter, you have it right there, and you have the diagram right there. This is one of the interesting topics in physics, and if you have a good knowledge of these topics, most especially those of us going for engineering, electrical stuff and all that, if you have a good foundation on the electricity in your O level, you will not find higher institution level difficult. So this is, I think, a summary of the potential difference and the instrument used in measuring potential difference.